Welcome back. In the stream from earlier today, we put together the basics of a game console. So here's my game with my 3D dude that we started rendering more efficiently a couple of streams ago. So we have a higher frame rate. And now I have this console that I can open, and I can type into the console, and right now what I type just goes into this backlog. And so I would like to be able to run commands in the console. What commands? Well, we'll get into that in a bit, but in general it's useful to be able to have commands that either inspect information about your game, will tell you things about the loaded level, or will process them. During the witness, we made a ton of commands just to do all kinds of things, right? It's just an easy way for a developer to hook stuff into their game. Now, in the witness and in Braid before it, there was almost like an entire mini language interpreter in order to implement this stuff, because if you want to, you basically want to set up commands so that you run a procedure with arguments. So say I wanted to do something that, one thing that we did in the witness all the time was I would say like find any entities of type door or even forget that. Let's take a simpler one. Let's say find true was like a command that would search for entities with a certain field set. So I would say like find if true, door, start closing sound, where start closing sound was like a string field. So this would return me a list of all the things of type door, and then I could select them and stuff and play around with them in the editor. So I'm gonna change my font back, because this font doesn't make the spaces very clear. So let's go back, and we'll make both of these in Consolata for the moment. So I want to be able to do stuff like that. I want to be able to type stuff like that and run a command. So we want a general mechanism for plugging in and deploying commands. So what I'm going to do first is just start to put in some basic parsing. But it's going to be a lot, or my goal is going to be to make it tremendously simpler than the kind of system we had in the witness and Braid, because we're going to use the metaprogramming to do cool stuff. And I already have a couple of ideas about how that's going to happen, but I haven't even thought through all of this. So part of this stream is going to be me playing around with ideas and trying to figure out what to do, which should be fun. Anyway, so the first thing we have to do is let's just make a new place where commands are going to run. So this file console is just going to be about implementing the console. It's 200 lines so far, which is pretty short, so we might be tempted to put command stuff in here. But the console is going to get juicier. It's going to have a lot more functionality. Like, we don't have scroll back right now. We don't have command history. We don't have pasting from the clipboard or editing. Well, editing the middle of your text probably goes in the other thing, but this file is going to have more stuff in it. So let's make a new file called commands, and this is where commands go. And I'm just going to type that and add the file to the project and add it to source control. And you know what? So we still haven't done anything, but that already feels like progress. It puts us in a good mood, because we actually, that's something further, right? We added a file and our game still compiles. It's always, get things off on a nice feeling. Okay, so here's what we're going to do. We're going to have something called run command And it's just going to take a line that's a string, and we're not going to return anything from here for now. I mean, we might think about returning a status or something. In the old system, you know, because I was thinking of it as like a full interpreter, I would like return the status code from a command about whether it succeeded or not. And you know what? We never use that. Nobody cares. So here's what I'm going to do. For now, we're just going to say print run command and the string. And let's hook this up to the console. So here we go. Here we're just adding that to the history. And we don't actually want to do that. We might want to do it later if we... In order to make the history more readable, we might want to add... Well, no, let's add it for now. Let's add it for now. And then I think later we might want to make the stuff that came from you typing be a different color than the stuff that came from the system responding, or you know, maybe we indent them by different amounts or both. We'll deal with that in a little bit. But then we'll say run command copy, right? Because that's our, well, it could be the copy or the text. We don't care. And we're just going to do that. So we're going to say this is a command. And we say run oh, string, what? I put string. I didn't want to say string. I wanted to say line. So that just printed the type, which was stupid and useless. This is a command. There we go. Run command, this is a command. So far, we have done nothing interesting, but we're just getting our structure here. Okay. So, now, we will break this into arguments and then run them. So first, well, let's do this. Cursor is just going to be, or remaining, this is just how much of the input line is left, and we're going to move over and chop this. And we're going to say the arguments is an array of strings, and we're going to say while remaining, which we have to be careful about, because remember we have this bug with empty strings that has bitten me a couple times. That's going to get fixed in the next compiler stream, but we're not going to do it now. So we need to be careful about that. And we're going to say while remaining. And let's go look at what we did in vars, right? Remember we had some kind of eat spaces? Yeah, so remaining equals eat spaces remaining. So any spaces at the front we're going to get, and then we're going to say from left, yeah. So we're going to say until space, let's find character from left, finding a space. Well, actually, let's do this. If we're done with the line, right, then, so if we have no text remaining after eating spaces, we break. We find a character from the left, and so if we did find, then remaining is advance, or is advance a, yeah, advance modifies its argument. I need to get consistent about this. Advance remaining by until space dot count, right? Otherwise, well, okay. If we got a space, Yeah, let's just do it this way. We'll probably be able to simplify it, but if we got a space, we advance remaining by until space, and we add to arguments the thing up until the space. If we didn't find, whoops, this is supposed to be array add. This is supposed to be array add arguments remaining, because remaining was not empty, right? And now we're going to say arguments, and for arguments, print some spaces, the index, and the string new line. It index it. So let's just make sure that worked. I don't know if that's going to work. Oh. Well, here, if we didn't find a space, let's just break. We could set remaining to empty string. It's a classic thing when you write a loop like this that you screw up and it infinite loops. So it's always worth it to go back and look like, am I sure that my thing is advancing every time, right? So right, so we had better have more than one character before a space because we ate spaces here. At the start of the string. Let's try this. This is a command. There we go, that worked. Isn't that lovely? Okay, so now we have an argument array, and what we're going to do is look that up in the command list. So we need a command list. So let's make one. Let's say there's a thing called command info. And it's going to have two things. It's going to have the name of the command, which lets us look it up. And it's going to have a procedure pointer that takes some kind of thing. I think it's going to be an array of any. I think so. For now. Let's see if we can tighten this up and make it not a runtime typecasting thing later. But for now, we're going to say arguments is an array of any. And for now, we're just going to pass these string arguments, and we'll make it better in a bit. We will, yeah, okay. So, okay, we already know this. That works. We already know this. That works. So, let's say init commands, because we need to add a command. Init commands, we will say, oh, and we need to store command info somewhere. So let's say commands is an array of command info. It's just going to be an array. You know, in the braid and witness code, like I think I store the command names in a hash table so you can like look them up fast, but that so doesn't matter on the scale that we're dealing with here, and it maybe makes it slower in some cases. So let's not do that. So init commands, I'm going to say add command. Let's say ls, and because we're going to duplicate a few of the basic commands from the witness, like navigating around and stuff. So when we init commands, we're going to add a command, and the proc is going to be called command ls, right? So let's make that scope file command ls arguments is an array of any, and we're just going to say print we called ls if arguments dot count is greater than 1, command error command takes 0 or 1 arguments. Now, clean up, do this via metaprogram. So here's the thing. Our commands are going to want to take variable numbers of arguments, for example. And yeah, and they're going to want to be of various types and stuff. This is going to be interesting and cool because we have this problem of going all the way from a string, which is really squishy data, all the way to precompiled stuff. Let's do something here. Well, let's hold on for a second. I'm going to get fancy in a little bit. Screw this. And we're just going to say we called ls for now. And or actually we'll say command output we called ls, and command output, because we want this to go back to the console rather than going to the print. So we're going to say, where do I, okay, so console add to history. This is going to be dumb, but it's just a wrapper. So even I do wrappers sometimes. Okay. So we're going to call console add to history s, and we'll probably want a more printf-y version of this in a second, so we'll get to that. But for now, we're just doing that. And here's what we're going to do. If there are no arguments, so the reason I'm making it an array of any I mean, I could use varargs, but like, why? It doesn't matter in this case. Varargs is for when you want to literally type a different number of arguments into the program text, which is not the case that we have. We've put this stuff into an array. So, so we command name is arguments of 0, and we're going to say for commands, if command name is equal to it.name, then if it dot, what did we call the member? We didn't put the procedure. Wait, what? Why did I put arguments here? No, arguments don't go there. We need a procedure. I don't know what I'm smoking when I do these strings. We need a procedure that maps arguments that I just had and returns void for now. That's what we need. If it dots proc of arguments. And maybe I should pop the argument off. Yeah, you know what? I don't want all my commands to have to think about the fact that they have to skip the command name as the first argument or something, right? So we're going to say non-command arguments is going to be arguments, but then non-command arguments dot data. Does that work? I don't remember if I made this work. So we're going to say equals the address of arguments 1, non-command arguments dot count equals, or minus equals 1. So we're just basically taking a view of that same array that removes the first argument. And we're going to defer 3 arguments. So after this array is done, or after this procedure is done, it's gone. So we break up the arguments. The first one is the command name. The non-command arguments are the rest. We search in the commands. If we see the name and it has a procedure, we call the procedure. Else, let's report an error, or we'll log an error. Right, so we're going to log print commands. You know, this is simple enough that I should remember it without pasting. Command whatever has no registered procedure, which is a really weird. I don't think that'll ever happen because the way that we register commands is going to have a procedure for sure, but whatever. Okay. You know, I should just overload free. I'll just do this for now. I don't have enough overloads for free, basically. All right. We want an array of any given array of string. All right. Let's make it an array of string for now, because we know I'm going to do something with this. But we know for now there's a string. Okay. Add command. I've not made that. So let's do that. So, right. So add command is going to say, just add to that string proc and we're going to say info is a command info.name equals name, info.proc equals proc, array commands, info. All right. Only 74 lines so far. Type mismatch. Oh, when I get a type mismatch between procedure pointers, I don't print it all out. So why is that a type mismatch? Wait, it's a type mismatch. Oh, because this still says any. I need better error reporting there. Let me put that on the list of compiler stuff. Okay. Good error messages are a good idea. All right, so we don't print unknown command, but I should be able to say ls. Oh, and we crash. Array bounds check failed. Why did array bounds check fail? Oh, because so we're saying it's equal to arguments of 1, even if we only had 1 argument. It was stupid. So if arguments.count is greater than 0, then we just do that. Okay. Still crashed. Did I had some weird problems with things not recompiled. Okay, let's get off LLVM first of all, because actually no, let's not, because I might have to debug this crash. Okay, so ls is crashing it. Is it just putting in 1? Yeah, it's just if it's 1. What am I doing? Oh, this is if arguments.count is greater than 1. I hope someone on the stream caught that. Yes, someone did. Thank you. What is going on? Semicolon. Oh, spammed an X into my... All right. So ls doesn't do what we wanted, but all right. So let's do two things. So let's say found is false. If we call the proc found equals true and break, right? So if not found, now we might be calling it and our command output isn't working for some reason. That would be weird, but okay, command output, command not known. And command name. And that's going to be a leak, but we're going to get rid of it in a bit, so we don't care. Command not known. Oh, the new line. Yeah, well, the new line is not good. ls, command not known. Oh, because we're getting, okay. We're getting the junk new line character on the end of our first word, which is not too surprising. Okay, so this is fine though. So why is that happening? Going back to the console, we want to catch that in the console. Actually, I guess that's all the way back in the text input, right? So right, so we're handling events in the text input. I don't feel like, let's just print what things we add. And I'm going to be very careful about typing. So I'm going to open this, I'm going to type ls 108.115, great, and then enter. Okay. It's something else is wrong then, so that's good. So I'm going to say, I'm going to print out the count, and hopefully this is 2. When I do ls, 2. And then, but down here, when I say command not known, count wa, command name, like I'm just probably screwing up the, no, what? Command not known count 2. Why am I printing 3 characters? Oh, because I put %s. I'm a dummy. I'm a dummy. This is not C++. Okay, never mind. I just did 5 minutes of debugging because I'm a dummy. I put %s out of habit from C++. No wonder it was always an S. All right, let's get rid of the LLVM for now. It's too slow. There we go, faster. Okay, so we've got command not known. Let's make this a better. So basically, command output is going to be printf-like. It'll just be this, and then command name right? And the way this is going to work is it's going to be just like one of these, like log print or whatever. We're going to say format is a string, and then args is a ... any, and we're going to have a string builder. Actually, no, you know what? Forget all that. We're just going to say, yeah, we're just going to say s is sprint format and the args, and then defer free s. That's it. That's all command output. See how easy it is to do var args now when they're not bullshit like in C? Oh my God. Try doing this in C sometime and have fun. Okay. ls command not known. Command not known. Oh, look at the varargs hooked thing. It's so great. Okay. Now, why ls is command not known, I don't know, because it should be known. Because we do add that as a command. So, testing versus what? Whoops, command name. All right. We're not, because we never call init commands. I hope somebody told me that in the chat and I didn't see it. Init console, it's init commands there. We got to call init commands. ls, we called ls. We've still got a new line there too. That's gonna, I'm probably gonna want to filter those out, frankly, but. Oh, now someone types it. After I say it, you guys say it. You got to catch it sooner. All right. So this is good. Now, the thing is, now we want to go from string arguments. In fact, let's do a command that takes numeric arguments and let's do a command that takes numeric arguments and does something trivial with them, but they need to be numbers, right, and not strings. So let's make a command add before we make ls work, right? And that takes arguments just like this. And we're going to add two numbers. So we need the number of arguments to be exactly 2. So first we're just going to write the dumb version of this, and then we're going to write the version that makes us not have to do all this dumbness all the time. So command output error add requires exactly 2 arguments, right? Return, and then we're going to do some kind of more powerful, like convert to integer. So like I0 convert to, or let's call it get integer arguments sub 0. I1 is get integer arguments sub 1. And if issued error, return, otherwise result is I0 plus I1, because there could have been an error, like someone might not have typed integers. Result is I0 plus I1, and then command output something plus something equals something. I keep putting the new line. Oh, someone caught it. Thank you. I0, I1, I0 plus I1. So we have to know what the numbers are, right? That's necessary. Let's just say result here, because we went and did that. And then what's issued error? Well, we will reset that every time we run a command. And we'll set it to true if these are not valid integers. Now remember, a to I, we're using the C a to I right now, which doesn't give us error conditions. I know I wrote one in an earlier demo several times actually, but it's probably not that good and I don't want to go digging for it. So we're going to keep using a to I, but we're just going to do a trivial check that the first, for the purposes of today at least, that the first character is a number, right? And we might do a more detailed one either on this stream or later. Remember, we did the same thing in vars, like we kind of cheaped out and, you know, just called a to I and left a comment here that like we want something better, right? So we're doing the same thing here. Get integer from an argument is as follows. If you give us something empty somehow, that's an error. And return 0. Otherwise, what's the first character of the string? If c is greater than or equal to 0 and c is less than or equal to 9. Actually, since it's an integer, let's test every character. For, this is just going to be the test. For 0 to arg.count minus 1, we are good, else issued error equals true, return 0. Okay, so and now we just say return a to CS is to C string, because we're calling the C standard library API, which has a 0 terminated string format, so we got to do this and defer 3 of the C string and return a to I of the C string. Okay, so add 3 and 5. Add is not known because I didn't register it, which is another thing that we will automate, but one step at a time. We need to, why not, someone is asking, issued error sounds like some Erno gnarliness. Why not return multiple values with a bool? Because the thing that I'm doing right now is in the end not really going to be user level. We'll see. I want to show, because this stuff that I'm doing right now is stuff we're going to automate. Okay, so add requires exactly 2 arguments. That's an error. So add 3, still 2 arguments. Add 3, 5, 7. No. Add 3, 5. Ah ha ha. Ha ha ha. That's our first command that actually does anything, right? So okay. This is great. I can get rid of that testing and get rid of this. Get rid of this. Okay. Get rid of that. Now, so the thing about this is we're getting arguments here and we're manually checking the number of arguments, right? And the types. Let's start with the number of arguments. In the witness and the braid version of this, when I register the command, I tell you how many arguments it needs. So let's do that. So when I register ls, and you can have optional arguments, right? So let's say the minimum number of arguments and the maximum number of arguments. And if you're within that range, then you have to do your own checking, but otherwise you don't, right? So ls maybe takes 0 arguments and maybe takes 1, right? But that's it, right? If you have more than 1 argument to ls, we're not going to do anything. I guess we could make it ls all those things, probably like Unix does, but that's not what we're going to do. Add takes no less than 2 and no more than 2, right? So then when we add command, we're going to say arg count min is an int, arg count max. I think, no, okay. And I'm just copying this stuff and then okay, whoops, that was dumb. So we have an arg count min and an arg count max. And so what we're going to do is we're going to stop type checking in add, and we're going to move that to the dispatcher, right? So, and here we're going to say, because this is going to start, actually let's paste that back there for a second. Because this is going to start getting bigger, let's factor it out. So run command it and non-command arguments. Okay. So run command is just going to say, what is this? It's a command info. Not a capital S. So issued error info.proc. So this should still work. Okay. Okay, so we want to use these numbers that we just stored to automatically check the arity of our arguments, right? So in this version of run command, we will say, well, we want to give the option of taking any number of arguments. And if you take any number of arguments, these will be -1 or something, right? So if, and we're using this, info.arg count min is not equal to -1, then we check and we say count, we'll just give a good alias, right? And if count is less than info.arg count min, else if count is greater than info.arg count max, right? So if info.arg count min is equal to info.arg count max, like if you take exactly a certain number of arguments, then we'll say that to give a good error message, right? Otherwise, we'll say something different. So we'll say command error, error requires exactly arguments, right? And info.name, info.arg count min. Otherwise, we say requires at least, right? And then down here, we're going to do the same thing. Except these are max. Command error. It wasn't called command error. What was it called? Command report? command output. Okay, we just said. Okay, so add one. Oh, okay, first of all, I got to get my new lines out of there. And second of all, I got to take this old thing out. Old and busted. Okay, add one, add, oh dear. Okay, we'll investigate that in a second. Oh, because I don't know why that crashed. Oh, because I'm still, dude, I'm calling the proc even if I reject it, which is stupid. The whole point in checking is that we don't call the command if there's an error. So there we go. Add 1, 2 works. Add 9, 9, 9, 9, 1, 2, 3, 4. That's great. Add 1, 2, 3, 4, 5. It doesn't like that. So now we have automated checking. ls abc. Most 1 arguments. So you know what? I get picky about having the trailing S. Argument string is a mapping from x is an integer to a string. If x is equal to 1, return nothing, otherwise return s. ls abc, at most 1 argument with no s. Add but requires 2 arguments. Okay. This is how you do English. Do you speak it? Of course. That kind of thing is fun to internationalize. All right. So, where are we at now? We have some automated error checking for commands. It doesn't extend to the types of the arguments yet. And now, this is where I want to try to do things very differently. So the system that was in grade or the witness would, you would manually declare the types of the arguments. So in the same place that we said, oh, this takes between 2 and 2 arguments, we would have said those 2 arguments have to be like this and that, right? And we could still do that. The thing is that we have metadata that will give us all of this stuff. Righto? You know what I'm saying? So, and there's at least a couple ways that I could try to do this. One way that I could do this is just generate this. Like generate this program text. And we're going to be generating this. Oh no, you know what? Let's do this the other way around. So that we'll have more picture of the options. Let's start doing cool metaprogramming now, but let's do the part that is easy to understand, which is instead of now having to manually add these commands, well, no, let's do it the other way around. Sorry, I'm vacillating. vacillating. So what I'm going to do is, this is experimental. Okay, so from this point, we're doing stuff that I really don't know if this is a good way to do it, because I don't have that much experience using the metaprogramming features of this compiler. But I'm gonna, this add command, right, what we're gonna do is, instead of taking a procedure of known type, we're gonna take a random procedure, right? And we're going to take a random procedure and we're going to call it See, we need to be able to call, like the ultimate goal, right, is to be able to do this, is to be able to say something like command add and not put an array of string for the arguments. I just want to say I0 is an int, I1 is an int, right? And then just say this. That's what I want. I want to get rid of all this other boilerplate. So what I could do, I'm going to do this thing called command front add that takes the arguments as an array of strings, does this processing, and then calls command add of I0, I1. All right? Now, for now, I am going to just do this manually, and then we're going to generate this as metaprogramming so that we only write this. That's the plan. That is the plan. So, well, generate this and these registrations here. Does that sound good? It sounds good to me. So let's go to our command ls also. Well, command front ls arguments string. We're going to say, what should we do in this case? I mean, ls really just kind of wants string arguments. So well, we can make it varargs, right? So we can say, or we can just say array of string. Like that'll be a case that we handle. So we're just gonna, this is just a pass-through, right? Okay. So now these are going to be command front and command front. Okay. ls add 1, 2, add 5, and 8, add 5, 4, blah, blah, blah. Okay, so this all still works. Dash M. Okay. I should just make a shell alias for svn commit dash M. Okay. Now, we want to generate stuff for these commands. And to do that, to get started on that, I'm going to show you something that I never demoed before that I do for an equivalent case for entities and stuff. So if I go into the entities file, here's a giant procedure called sokoban emit. let me actually even give some context, right? So remember that we have compile time metaprogramming, and you can run your metaprogram and it can inspect your whole code and all that stuff. Now, one challenge, or it's maybe not the biggest challenge, but with regard to making your program understandable, if I have some code that generates entity data and things that operate on entities, but it lives far away from the entities, like way over in the compile time metaprogram, and is jumbled with a bunch of other stuff, that makes your program hard to understand, right? If I want to do metaprogramming that operates on the entities, I really want that in the same file with the entities. And so here's what I did, is here's a procedure that looks through the code for all the defined entities and then generates some functions that map names to entity types and whatever. It does a bunch of things, right? And I just tag that with this note, run when all parsed. And I have to run this at a certain time, right? If I run this before all the entity types are declared, then I might miss some, and that would be very bad, right? So run when all parsed says, wait till that phase when we're done handling all our source code, and then run this, and this will add more source code. We demoed that way back like a year ago in the compilation phase and workspace demo, which you could find on YouTube. Not this exact thing, but we demoed like looking at phases of compilation and all that good stuff, right? So let me show you where this happens. It happens here. So basically we get a message for some piece of code, and if the message is that this code is passed type checking, we check the notes on it. And right now, if it's run when all parsed, then we add it to some list. And when we get to compilation phase, oh, we're done, then we do this, right? So we're going to do a similar thing, but with commands. So we're going to say else if it.text is equal to register command, then array add commands to register, and yeah, just the declaration's name. That'll be fine. So all right, and then here I'm just going to print at first register command. Whoops, this is commands to register commands it, right? So if our metaprogram is working, then that's good. So we're going to go here and we're going to say at register command, and we're going to go, where's command ls? I'm going to move this to be next to command add because it's easier to find. Okay, so we're going to register those commands, and let's see what happens. Well, we don't run any differently, but here we go. You see when we compiled, we register command ls, register command add. So let me reiterate that despite the fact that we compile in like 1/3 of a second, which is tremendously faster than a C++ program compiles for a 37,000 line program, we also are doing way more because we're passing messages about every single thing we compile to this metaprogram, and the metaprogram's handling them. We're doing just a lot more than a C++ compiler does functionality-wise. So, rant off. We are registering these commands, and what we're going to do is header is going to be a string that goes, let's just generate this thing. Oh, this is going to be tricky. Let's just do this. I feel like I want to take a 5-minute break soon, so let's just start. The header is going to be init commands. We're going to just generate this procedure, right? So tail is going to be the close brace, and for commands to register, we're going to say body is an array of string. No, actually, let's just say lines. Lines is an array of string, and we're going to add to lines. The first line is going to be the top of the function procedure. The last line is going to be the bottom. Whoops. Right? And then for commands to register, we're going to say, we're going to call this init commands B for a second, because we don't want to replace this quite yet, because remember we have this argument checking logic that's going to be more involved. For now, as a first step, I just want to generate a procedure that gets compiled in that has this stuff. And I'm going to say, min args is -1, because we're going to want that later, right? Min args is -1, max args is -1. Line is sprint. You know what? Instead of command front, let's call it front command. Well, no, let's not do that. Yeah, let's do it. The reason is because this string is called command add, and I just put front on it, on that name, to get the name of this other thing that I actually need to call, rather than like inserting something in the middle is just a little more awkward. So we're going to say front underscore and the name, parens, and then a quote, escaped, and then the name without the front, and then a quote, and then comma, right? Let's look at what we're doing here. Init commands. Actually, let's call this register commands, because init commands, this is a thing we call from main, and it might have to do some stuff other than registering commands. So this will call register commands, eventually, not yet. And register commands adds these lines that look like these. So we say front. Oh, sorry. It helps to look at this, right? So for every line, we need to say add command, open paren, okay, then a quote. I was doing things in the wrong order. Then a quote, then the name, then a quote, comma, and then this front stuff, comma, and then 2 numeric arguments, semicolon, new line, right? And let's put 4 spaces in there to indent it. And the arguments are the name again, min args, and max args, right? That seems good. And then once we've generated this, we will add result is concat lines, free result, that's a leak. We're going to free this though, and we're going to, well, no, because I don't know if add build string copies. So add build string result message.workspace, right? I missed a comma, someone says. Maybe I fixed it. Oh no, I didn't fix it yet. It's up here. Thank you. Okay. So in theory, this will generate something like this for any command that we tag with this register command tag. And it doesn't have to be called command whatever. Now, we're not yet analyzing the arguments. That's something we'll do after the 5-minute break. And honestly, I hope that I provide enough metadata, because sometimes I sweep things under the rug to get things done. So I wonder if I even provide all the argument types. If I don't, we get to do some compiler work. If I do, then whatever. No concat? What? Are you kidding me? Where's concat? Oh, it's concatenate. Right. Concatenate wanted a string given, wait, what? Oh, right, I got to spread it. Spread it, because it's a var_args procedure. Okay, undeclared identifier. That would be a good case for a good error message, right? This should have said, it could maybe even give this message and then say, oh, this is a var_args procedure and you're passing it an array, please spread the array. It could have said that. Let me make that a small compiler thing. Concatenate var_args error message. It's always good to stay on the lookout for that kind of thing. Okay, undeclared identifier add command. But look, it says that out here. Okay, here's the problem, and this is something that I don't have a way around. We do have an add command, but it's in file scope of this procedure, and this is being added in a totally different scope, and we don't have a way of saying add this to file scope of some other file yet, if we ever have that. So this has to be global. Undeclared identifier front command add, what? Whoa, I'm putting command add all over the, what? Oh wait, oh this is confusing because command adds a command to the array, but command add is an actual command that adds numbers. I've picked confusing names. Oh boy, okay, so these also need to be global, but that won't be a problem because we're going to generate them. So these are temporary, will be replaced. So that compiles. And we're not actually running this thing that we just generated. Okay, 5:39 p.m. So let's type that. Okay, this is entity stuff that I generate. And there's my register commands, right? It's the first few lines in the thing. It says add command, command add, front command add, -1, -1, and command ls, front command ls, -1, -1. So I'm going to take a 5-minute break. Actually, are there any questions before the break? Then I'm going to take a 5-minute break. Then we're going to come back and get these argument numbers correct. And then we can actually swap this in as the live thing. And then after we swap this in as the live thing, we can add this stuff. How will this help in finding the variable? Nothing will help in finding the variable. Is metadata all type checked at compile time? Yes, you can watch some earlier demos if you want to see how this stuff works. There's a lot to talk about, which is why I really don't want to go into it this time. There's like hours of YouTube videos about how this system here works. But by the time we get to this point, then the command procedures that we want to register have been successfully, lexed, parsed, and type checked, yes. Oh, good point. Someone just said, so I can't take my break yet. Someone just said, and this is correct, the name in the string is wrong. And because we're registering these things as command add instead of add, what do we want to do about that? I could think of two things. But what I'm just going to do is, I'm just going to say if it starts with the word command, then chop off the word command. Otherwise, leave it as it is. And I think I have a starts with, no. Oh, well, this would be in the library. Oh well, we'll write it. So what we're going to say is command name starts at it, and if starts with, okay, to chop is command underscore. So if the command name starts with what we want to chop, advance command name by to chop.count, otherwise don't do anything. Now what starts with, let's make that global because other people are going to want to use it. Starts with a string, whoops, a colon string, prefix. Oh, is it called prefix? I don't know. Let's look in compiler really fast. Prefix, nope. Okay. So, does this start with a prefix is very simple. If a.count is less than prefix.count, they can't possibly write. Otherwise, I'm going to make a b is a, but b.count equals prefix.count, and return strings match b prefix. Done, I think. Undeclared identifier strings match what? Oh, let's just say b is equal to prefix. Ta-da! Okay, so now let's look in. That didn't work. Why not? It is correctly timestamped. Starts with command name to chop. To chop is command underscore, which is what's at the start there. So what is our problem? Yeah, well, we should declare it. Why am I running? We don't need to run. B is command underscore prefix command underscore. I bet it's another compiler bug around strings. No, wait. Starts with. Oh, because I'm not adding command name. I hope someone caught that. I do that all the time. I go through all the work to like make a new variable and then I don't use the new variable. Okay. Well, I don't need to do that because we're not actually running these yet. Okay, so there we go. We have chopped the word command off the front. Why do I only have 2 spaces here? That's communist. Okay, are there any questions before I go to 5-minute break? My tea is cold. I need more. Anyone? 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 Okay. Nobody seems to be asking questions. People are talking about Java. I don't know why. Yeah, I was checking for arg count min equals -1, but not max. And that's because if you don't want to disable checking or have varargs, then they both should be -1 is just the convention. And because we're auto-generating this, we can enforce that and there won't be user error. Like if you want to accept at least 0, but some max, then put 0 and whatevs. Okay, 5-minute break. While I'm on break, 5-minute break. During break, you can familiarize yourself with the type info procedure on the left, which we will use when I get back. Is there a way of changing error messages outputted by the compiler? Not currently, but I want to add a way to do that, for example, to internationalize them. That will happen eventually. Is this using body text? No. This is using a compile time metaprogram, which is different. I mean, body text is also compile time. This is using the kind of metaprogram that runs the compilation of your program. And I'll be back in 5 minutes. Okay. So, yes, we are in the middle of using metaprogramming to simplify the kind of command system that we used in the witness and braid, so that the programmer doesn't have to do as much hassle in terms of registering commands and doing type checking and stuff. I could do something like register command add, and we might add that option later. There's all sorts of options we could add, but for now I just want to get the basics and then decide later what we really need. But yes, you certainly could have people specify the name in those little register command tags. Here's what I was thinking though during the break, which is just, in my experience, we almost never want like a vararg string argument in a game. Like we almost always know exactly what the arguments are we want. So I'm going to take out this special case for now, and if we really want it, we could add it later. But if ls takes 0 or 1 arguments, then we'll say arg is a string that equals the empty string by default. So this will be analogous to what's happening here. Now what I want to do now is, when I see this register command tag, I want to look at how many arguments there are and use that to fill out, where'd it go? Fill out that thing in init commands. Let me find it. Right, fill out this with the proper numbers. And what I'm not sure about, and what we might postpone, is I'm not completely sure if the metadata for procedures tells me if they have an optional argument yet or not. And we need to know that to make these numbers different. So if we don't have that information yet, then what we'll do is we'll make these numbers the same all the time and still get type checking, but not have optional arguments until I go and fix it, which if the stream goes well, we should be able to do by the end of the procedure. That struct is not a procedure. That struct, so this that I had on during the break, this is not a procedure. This is the type information for type about a procedure. So now what we're going to do is when things come in like this, we're going to check that they're procedures. And if they are, well, if they're not, we're going to complain. And if they are, we are going to use this information passed to us by the compiler to fill out the command registration. And it looks like I don't see anything on this struct to tell us that something has a default value. So I believe that I'm going to have to fill that in before the end of the stream. I may not go as far as copying the actual values into this struct. I might just say, here's how many non-default arguments there are in this procedure or whatever. Anyway, so some things will become more obvious as we go along. Anyway, so let's go to here, and this is going to be a big enough thing that let's filter it into its own thing. So we're going to say generate code for commands, and that'll take message.workspace. And we're just going to pull this out, put it into its own thing. Okay. Now, we're still doing all the same stuff. Now, these declarations that we have in commands to register may or may not be procedures. And so what we get here is a declaration. Let's look at all this stuff from the head down. So we're looking at, we've got a good looking compiler. We're getting one of these messages that basically just says, oh, this declaration got type checked. So we're saying, okay, we got this message, let's get out the declaration. That declaration has a bunch of info, right? It tells us the name of the thing, you know, what the type is, and a bunch of flags that could be there. What we want to do, well, let's check, and also this is sort of a child of code node, so let's look at code node for a second. Code node tells you, of course, what kind it is, and then it's got some node flags, which are general things that could apply to most expression types, and you know what file name it's in and what line number and stuff. So we're not really going to use any of this information, but you might, well, we might for error messages actually, because we're going to generate some error messages. So now what I really want is the type. It's been so long since I've done this metadata that I forget how to get the type of the thing. Remember, we've got all these type infos, right? So we need to get at a type info somehow. So I'm just going to search for type info here. Oh, it's in code node, right? Duh. I went right past it when we were talking about this. So here's what we do is we say let me get rid of that scope export. So in generate code for commands, I'm going to say for commands to register, type is it.type. If type.kind is not equal to, let's go back there, because this is a basic type info. If, oh, it's type.type, sorry. If type.type is not equal to type info tag procedure, then print error, some declaration. Actually, let's put the file name and the line number. Declaration is tags. What was our tag called? Register command, but is not a procedure. You are a bad person. And continue. And let's put the file name. It dot file name. It dot line number. Right. So that should not trigger for us. Whoops. Whoa! I screwed up. Okay. So before our simpler version of this, I didn't need the whole declaration. I just needed the name. So our commands to register only stored strings, which was the name. But now we want to store a pointer to a declaration, if I could type. And here we just add the declaration instead of the name. So I passed the workspace incorrectly. Oh yeah, because I factored this, there's no message anymore, there's just workspace. Okay. Oh yeah, so remember, this isn't anything to do with what I just did. Remember at the start, when I started up again after the break, I said I'm going to change ls. Well, I didn't actually do that, right? So if, why did it say arguments? That doesn't make sense. So if arguments.count, arguments of 0, command ls of nothing. This is a little bit awkward, but we're going to automate this kind of thing, so it'll be totally fine. All right. So nothing new actually is happening yet, because we didn't even change our code generation, right? So okay, now we're going to start changing our output string. So remember we have this min args and max args, and what those are actually going to be to start is, well, let's say proc info is cast pointer to type info procedure of type. So type is a type info, which is the base class, and so we're casting from this type info to one of these type info procedures that I left up during the break. If you've watched previous demos, I've demoed the hell out of this stuff. So if this doesn't look familiar, there's like hours of videos on YouTube that you can watch me playing with this stuff. But all that stuff was for toy programs, whereas this is for a real program. But the application is still straightforward. So I get the info, and I'm just going to say, that args is proc info.argumentTypes.count. And we're just going to set both of these to args, because we can't tell yet, info. We can't tell yet which args are optional, because the compiler isn't exporting that information. But the good thing about being the guy who writes the compiler is I can fix that today. So well, we didn't need to run, but if I go to the thing, oh, why didn't I, what happened? Wait. Okay, I wasn't looking at this. Why, what's going on? Oh, you know what? Well, I don't know. Maybe I'm looking at the wrong thing. Maybe I'm looking at the wrong thing. It is a percent type dot type. It is a void. Void. That's the return type. Why am I getting the return type of the procedure? Let me make sure that's the return type. This is entertaining. I'm going to make that one return bool. Whoops. True, not Tuesday. So I made that return bool. Oh, it's still void. Okay. Well, let's do it this way. Let's, so first of all, these declarations need to have an expression anyway. So let's go back to, whoops, compiler. So we have a code declaration. So I'm not sure why I'm poking a void type onto the declaration. That strikes me as fishy, and I'm putting that on the list to investigate. Void type on code declaration. Now I'm hoping that the type on the procedure is there. If that isn't there, then we really have some compiler work to do. But I believe that I can just look at root expression. So if it doesn't have a root expression, then we get a different error. Declaration is, but is not bound to any expression. So that's like, you know, you could say some variable is a certain type but has no value. And that's no good. So we complain about that. It's no root expression. Otherwise, it.root expression.type. Let's try that. Whoa, okay, I'm printing something weird. Oh, because I changed what it is. It used to, well, yeah, it used to be the name, and now it's the declaration, so this is a pointer value. So now it's not a pointer value. Okay, so there we go. So we're saying add command ls, front command ls 1, 1, add command add, front command add 2, 2. So we don't know what are the optional arguments yet. We haven't supported optional arguments, but we can finally make this go end to end if we're not going to let ourselves do optional arguments yet. And we'll do this. We'll say init commands doesn't do this anymore. It calls register commands. Hey, look, it compiled. Let's run it. ls. It requires exactly one argument. Why? Because we passed 1, 1. Foo. Well, ls doesn't do anything. Add 3. Oh, add 3, 5, 8. So that's good. Oh, we haven't added quit. That's only in the witness. -m auto registration of commands need to do default arguments. Now, we are about to change contexts a little bit because I need to go into the compiler and export more information that we don't have. So this would be a good time to take questions, if you have questions about what we just did. Since this is working, I'm going to just delete this. Register commands is generated by the metaprogram by generate code for commands in first. Yeah, I'm going to make an alias at some point. General questions, like off-topic questions, we'll do at the end of the stream. Now is on-topic questions about exactly what we were doing. How do you deal with variadics in argument types? Well, you would detect that here, right? So this type info procedure, right now I'm not quite giving enough information for that, but this would just tell you, well, actually, the procedure flags would probably have that information, that it's a variable argument procedure or something, and maybe that flag isn't just being exported yet. But it would be straightforward if you had all the information. All right, that seems to be all the actual questions. So everybody's asleep, nobody cares, but we will forge onward. Someone says metaprogram data is generated at compile time, correct? Yes, let me be explicit about that. So this added strings file is generated by the metaprogram, essentially, and mixed into our code. So this ends up being an extra file that gets stuck into our program, and basically we just added this to that file. And for every command that we add, we will add more. Will this handle overloaded procedures properly? I think so. Yes. Not yet. Well, I mean, because we're going to generate these front commands, right? So, yeah. Okay. Now, let's go into the compiler, and what I'm going to do is I am gonna just add something to type info procedure of number of non-default arguments. This is kind of a cop-out because you really want to know the default values for everything, but for now that's all we're going to do. So we're going to say number of non-default arguments is an int, incomplete. This is a cop-out. In future, we want to know all arguments default values and then derive this fact from those. And maybe, I mean, if we're doing super good by the end of the stream, we might go do that. But for now, because I haven't worked on this system for a while and because we're in the middle of a live demo, I am going to try to keep it a little simple. Okay, so I have to go into the compiler now. So now we're going to be looking at C++. And we are going to go the messenger, which sort of echoes all these structures. So in C++, oh no, actually, type table is where the type info is. So here's our C++ definitions of the type infos, and here's procedure, and use64, number of non-default arguments. Right, so then, in type table, let's look for something that sets procedure flags. Well, actually, so anytime you add a field, there's stuff you got to do that in my language would happen by metaprogramming. So this is just a thing that compares two of these structs to see if they're the same for all purposes that we care about. All right, so this is the part where we're actually exporting the data. We've exported arguments and return values, and now we're setting procedure flags. We're mapping from the compiler's idea of procedure flags into the exported data's idea of procedure flags, and they're not the same because you want to be able to change compiler implementation details without changing what's exposed to external programs. So here's what we're going to do. We're just going to set that, and we're going to say int non-default args equals 0 for int I equals 0, I is less than oh no. Oh no. I'm doing this in the wrong place. This isn't that bad of a thing, but I'm doing this in the wrong place, which might be why the information is not there. So here's the thing. I'm trying to put this into the procedure type for this procedure, which is not where it goes, because you want two procedures with the same types but different default values to type check to the same thing, because you could call both of those in the same way, and you could assign both of them to the same procedure pointer. So this is me being rusty at this thing. We don't want any of this, I think. I mean, who knows, in 10 seconds I might reverse everything I'm saying now, but we don't want to modify any of this type stuff. Types do not have that information. What has that information is the individual procedure, which is in here. So, whoops. So a procedure, which should be pointed to by that declaration's root expression, by the way, has its own, oh, we might know what the arguments are, but we don't know for sure. We don't know for sure if they're optional. So I'm going to do this, start doing the same thing, but it's here in the actual procedure, right? So then we go back to type table. Someone's asking, do you have basic parse this type from string stuff in the standard lib, or did you implement all this? I implemented it for the games console, and you can watch that stream, but what I did was very trivial and not even complete. So, I mean, I'm calling like C's A to I if it's an integer or whatever. Like it's very minimal, and we'll do a better version later, I think. Okay, I want to get this done. Type table procedure. Wait, it's not in type table, it's in messenger. So types go in type table, but messenger has all these different other nodes. Okay, so let me just find, where do I set the procedure flags? That's always a good, okay. So we're in here, yeah, we're right where we were. So, same thing I was doing. So num non-default args equals 0, and we're going to say result that equals num non-default args. This is an int. We're going to say for I equals 0, I is less than args.items, I plus plus. Now I need to know from the argument declarations, how do I know if it has a default value? Do I just do that by if it has an expression? Let's try that. Here's all my declaration flags. Yeah, I think we just see if it has an expression or not. So if, well, auto arg equal arg decals of I, if arg expression, our first default argument, break, else, we don't really need the else, but whatever, non-default args plus plus. So we're counting, hopefully, how many arguments we really need. Let's close this. That's for debugging Sokoban from hours ago. Let's close Photoshop. We're not doing pictures right now. Let's close the witness. Let's open the compiler and let's go to release mode because we're optimistic. And something failed. It's so hard to see error messages, and they have this like, they have a mode that's supposed to only show you errors, and it's even worse than this output, so I never use it. Number of non-default arguments is not a, oh, that must be left over from the last thing, yeah. That is no good, all right. Now, what expression is not a member of code node? Arg root expression, right? I don't know about this. I feel like we do not have all the information we need. I feel like this is going to end in tears if I don't do something else. Let's make it a U32. And that means make that a U32. So in theory this is done, but the problem is I'm not sure the information. Let's see what happens when we export a declaration. Oh, no, I bet it's set. Let's have faith that maybe this all works. Let's see. See what happens. I guess I didn't need to run that time. Oh, I got to recompile the compiler to make sure it's up to date. Oh, I didn't even fix everything. No wonder nothing bad happened. Root expression. Okay. Wait, what is arg? Arg decals is a code node. Let's not even look at that. That's output. Let's look at source arrow argument declarations, right? Is that, so what I'm trying to look for is lambda here, hopefully stores declar. This is how long it's been since I've looked at this stuff. What? You gotta have declarations. Oh, it's on my type. Yeah. I think it's fine. Right. my type. So all lambdas have a type instantiation, I believe, if this fact didn't change at some point. No, it's not here. I don't even know my own compiler. Lambda, argument, declarations. Okay, that exists on type definition, that's fine. And that's it? That's it? I am so unclear on this. Let me go to this thing we were looking at in several streams ago, where we actually sort arguments and decide if there's default arguments, because that's how confused I am at this point. Okay. Declarations. That's for names. Where do we fill in the default arguments? Here, we look in declarations. We say if it has an expression. That's fine. So where does declarations come from, I ask you? Well, we pass it in. We look in, okay, yeah. It's in the inferred type. All right, that's fine. That's not how I thought it was, but it makes sense. Okay, so let me just, so that we know we're not getting like complete garbage or something. Well, let me keep forgetting to compile the compiler. Argument declarations is not a member of type def, what? Inferred to, oh, lambda argument declarations. It is called. Okay, the compiler is compiling for the first time in a while. Yay, we like that. Okay, so now we're actually running the newer compiler. It didn't barf on us, which was a possibility. And let's go back to our metaprogram, and we will just print. Remember, okay, well, let's make sure. So since after here we've checked that it's a procedure, and now we'll say lambda or proc, I don't know, let's call it lambda. Okay, so the structure we're going to be looking in is called code procedure, and it's got this new thing that we added called number of non-default arguments, right? So code proc is passed pointed at code procedure, it.root expression. It is the declaration, remember. So the declaration's expression has to be a procedure because it exists and it's of type procedure. So we do that, and then we say args, non-default args is code proc dot, and we're just going to print this. Some name non-default args is that it.name non-default args. Whoo! Command ls non-default args 0. Command add non-default args 2. That is correct. This all worked the first time for some definition of the first time, right? Because so for command ls, right? We only have one argument, but it's got a default, right? So our minimum number of arguments is 0, and then here our minimum is 2, right? So all we do is here we say non-default args. So when we call one of these, we have to pass anywhere in between min args and max args, and we run, and we ls. We called ls, and we ls with a thing, and that's great, but with two things, that's no good. Add add 1, add 1, 1, add 5, 9, add 5, 9, 11. Isn't that great? Isn't that great? And you know what? Okay, let's add another command that takes no arguments because, you know, sometimes that's when we barf, is when there's 0 things. Is it called should quit game or something? Yeah, should quit game equals true, and then we'll see that next frame and whatever. And then front command quit command quit. Now, we still are using these fronts, but then the next thing we're going to do is generate all these. These, you know, these do the parsing to the specific type. So we're going to, well, we're going to do that. And that's going to be awesome. All right, so add 4, 5, ls, doesn't do anything yet, quit. Boom. Okay, we properly detect number of arguments and etc. This is putting me in a good mood. Is there anything, any questions about this now, what we've done here? People are interested in the random quotes in the chat. Does anyone have a question about this fine facility of metaprogramming? Oh yeah, check in the new compiler stuff. That's a good point. Info procedure. Wow, I changed a lot of things, actually. I guess I should have checked that in a while ago. That's got stuff from the last demo, which is why. Well, good thing we checked that in. How will we generate the fronts? How will we ever generate the fronts? Well, let's start. Let's start. We're going to generate them as comments again, just to replace this, but then we'll uncomment them when we're ready. When we're ready. Okay. Curious on why the files in the standard library are capitalized? I don't know, I just did that. What commands are you really going to add? Hundreds of them? Like, I explained that at the beginning of this stream. Games tend to want a lot of commands that developers can use and easily hook into. And what I'm doing here is I'm making it maximum easy to add new commands. Will the metaprogramming for this game be easily translatable to any future games with in-game command line? I believe so. What I would like to do is make this as abstracted as possible. Do I find that using metaprogramming across projects is any more or less portable than normal code? Dude, this is all new. I don't know. I don't have decades of experience using these facilities. I cannot answer that question. Dude. Let's start generating these fronts. Let's start generating all these fronts. Okay. Line equals sprint. Oh no. So now we generate one front procedure for each command. Put an extra new line there. And now we say, once again, let's say first we generate register commands. Then we generate one front procedure for each command. So 4 commands to register. Line is sprint. Open comment, new line. Front, name, colon, colon. Arguments is an array of string. There, new line. Array add lines, line. That's going to leak, but who cares? Then array add lines, close brace, new line, new line. Oh, close brace, new line, close comment, new line, new line. So this is just going to be an empty procedure that's commented out for now, and then we'll fill in the body of the procedure. So we just compiled, it's fine. So now let's more this file. There we go. Oh, I didn't put the name. I should have error checking on that because I demoed it like 2 years ago, but I just never turned it back on. So it.name. How do I differentiate command from non-command prompts? I guess you weren't here for that. We just tag it. See this register command note? Anything tagged that way will get fed into this. All right. There we go. So we're generating now the shells of these procedures. And now we want to go over every argument. And okay, so for now, let's just say every argument is either a string or an integer. Yeah, this is how I'm going to do it. This is going to be a little funny how I'm going to do this, and there may be a better way to do it. But remember that I'm not exporting the data. We'll get into this. Okay. So we'll say header, tail, and body. With the body, what I'm going to do is I'm just going to generate one line per argument, and then I'm going to generate this and this, right? Let's do this, because that's easy. Array add lines, that. And then let's add this call. Let's say for, well, let's kind of put this in its own scope to keep it neat. Args, I don't know what to call this because we've got arguments all over the place and whatever. Arg string. Oh no, you know what? Here's what we'll do. Arg strings is an array of string, and we're going to say for 0 to 0 to what's the max args? Do we have max args available? Max args is up here. That's not nice. Okay, we have a slight impasse. Let's pause on what we're doing here for a second. Well, let's finish this. We'll say we're going to add the string incomplete, and arg string is concatenate the arg strings, and array add lines arg string. Oh no. print command, no, not even command, but the actual name, open paren, arg string, close paren, semicolon, new line, it.name. Okay. Before we get into this complexity, what did I get wrong? I didn't get the right number of parentheses, which is not surprising. All right, so let's more that. Okay. Oh wait, I put the word arg string. I am on some serious drugs. Okay. So let's put some spaces in front of this issued error, right? Compile. Here we go. So this is starting to look like what we want. So the problem is we didn't save the argument info. So we would have to like reinsert redundant code to rederive it, which ain't so good. So let's save the information that we derived when we generated the registration proc, and then we'll use it again here. All right. So we're going to declare a struct here called command info, and it's going to have a min args is an int, and a max args is an int, and a declaration is a code declaration, and that's pretty important, so let's put that there. And we'll have command infos is an array of command info, and for every command that passes our little validation here, we're going to say info command info array add command infos, info, and when we do that, we're going to say info.min args equals min args, info.max args equals max args, and info.declaration equals the declaration, right? Oh, equals it. Okay, now for command infos, let's just do that. So where did we use it? We'll just make that decal. Okay, so now we have the min args and max args. So here, instead of saying incomplete, I'm going to say for I it.min, let's call it info. Why not? Info. I is info.min args to info.max args, and arg strings dot or add to arg strings I so we want to put the comma in is the tricky one. Percent, we'll do that later. If I is not equal to info.max args, array add arg strings, the comma, right? Oh yeah, I changed info. I changed it from it to info. And I changed it from, that's I. All right. Okay, hey, that's putting args. Oh, wait, what? I2? The hell? Oh, because, okay, we don't want to go min args to max args. We want to go 0. I hope someone caught that. Oh, the issued error thing should be at the end. Yes, thank you for catching that. Okay, let's actually, okay, call the non-func proc. Oh wait, no, we want it at the beginning. It has to be before the call. The thing is, we haven't inserted the type checking yet. So that's nothing yet, and then that. Okay. Okay, so, okay, this is more reasonable. So, you know, add, oh, we need a -1. Thought I was being smart. Okay. Oh, I thought I was being smart. Okay, here we go. There's 2 arguments to add and 1 for ls and 0 to quit. That's great. So now we just have to initialize the arguments. Does it always exist within an iteration if you alias it to another name? The way it works is, here there's no it because I called it I, right? If you don't give a name here, it's called it, right? Or here there's no it because I called it info, right? If you don't give a name, it's called it. You're saying the parser should accept f of x comma, maybe it should, and maybe that'll make metaprogramming easier, actually. So I should think about that because it's probably kind of rare to make that mistake legitimately and need the compiler to correct it. So I'm going to write down that the compiler maybe should accept f of x comma, because that's a good point. Okay. Now, here's what we're going to do. We're going to only handle 2 argument types so far, and then we'll expand that out either later in the stream or in future streams. We're going to look at the type of each argument, and if it's a string, we're just going to assign this variable to a string. Otherwise, it's an integer. So here's what we're going to do is we're going to iterate over all the args again. And after we do that, this is going to be initializing all the variables. And then this is going to just add a new line. So we're initializing the variables, and I'm just going to say array add lines, 4 spaces, or print 4 spaces I percent colon equals incomplete, which is fine because it's commented out. We're just getting the structure of what we're doing, and then I like that. Whoops, gotta quit the more. Okay, so there we go. I0 is incomplete, I1 is incomplete, and command add. All right, and we still run. So while the going's good, let's commit. About to do cool stuff. Okay, here we go. So we are now going to look at the well, we will recast the type info procedure. Where do we do that? That's down here. Okay, we already have it. Never mind. So we have code proc, which is that type info procedure. Let me go back there and show you guys that. It's in preload. So that's got the argument types, and we know that our max args is equal to the number of argument types, or the compiler did something broken, which hopefully is not true. So let's say arg type is info proc.argument type sub I. Now, what type is it? If arg type dot type, I think it's called type, yeah, is equal to type, well, we already, if it's integer, else if arg type dot type is equal to string, else print error, no, let's not be error, let's copy one of these, procedure argument percent is of a type that is not handled yet by command registration. Okay, and then that's decal.line number, decal. What file name first? Decal.file name, decal.line number, and which argument is I. And don't we do have a compiler report error, actually. Let's use that, because this will stop compilation if we use it, which in a case like this we want to. And we might even want to change the earlier stuff to report error, but this is more serious. This is like, okay, your command isn't going to work. Okay, let's break this up a little bit. So we're going to add a thing called line, and line is that. And if it's a string, line is going to be one thing. And if it's an integer, it's going to be another thing. If it's a string, we're just going to say it's arguments of I. Because remember, arguments, arguments is the thing that was passed in. That's an array of strings, so we just take a string out. If it's an integer, we will just call get integer, right? And if that generates an error, we'll catch it with the issued error later. So get integer arguments sub whatever, new line, I, captain. Info proc, what did I call it? Code proc. No, proc info. Proc info. Undeclared identifier proc info. What? Oh, that was, okay. Let's put it in our thing. Info.proc info equals proc info, because why not? Proc info, type info, procedure, and then this will be integer using type info tag numbers. Oh, what the hell is that? I gotta fix that bug. Well, wait, it's not coming out. Okay. Type mismatch, argument 3 of compiler report error. Oh, character index? Is that what you want? Let's go back. File name, line number, character number. Decal.character number. Too many arguments. Wanted 4, got 5. Oh dear. Compiler report error just takes a string. I need to make a version of this that's printf-like. I don't have that yet, so let's just do this. Error string, incomplete, make a version of compiler report error that is print like. See, I come up with all sorts of things to do just by writing real code. Error string is sprint with I, and we're just going to leak that because we don't care. End of input from within comment. Oh, because I'm commenting the front and I'm doing all this stuff. Well, I don't know. Let's see. That's interesting. Have I created other games before? I don't know. I mean, making games is just a thing. Wait, I screwed something up. I screwed something up. What? Because we were doing better than this before. It's like I'm concatenating the thing to itself. Oh, duh. This is a thing that needs a compiler warning because I didn't really declare a variable out here, and I'm setting it, but I'm declaring new variables in each of these scopes, which is really easy to do when it's just a difference between a colon or not. And that's common to a lot of languages that have this kind of syntax. Whereas it would have been really easy to say, oh, you're using this, you're declaring this line variable, but you're not using it. So what happened was we inherited this one from way up here, which is not what we wanted. Okay, so let's look at that. Well, okay, right, quit doesn't have any arguments, so that's fine. Command ls just takes a string, and command add gets integers. So we're almost done. Okay, the one thing that we're not really doing is handling the optional argument part of and I'm not sure what the best way is to do that. This is the one little sticking point. Let me think about this for a minute. We have very good progress. I'm going to take another 5-minute break. When I come back, we can think about this. Because yeah, I think I might know what to do. It's going to be a little goofy, but we'll do something. 5-minute break. 5-minute break. 5-minute break. 5-minute break. 5-minute break. Someone, let me come back here for a second. Someone said parameterized at annotations, and that's fine, but I don't want to require the user to do anything. I want this to just work. So we're gonna make this work without the user having to do anything, even if the code we generate is ugly. But if the code we generate is ugly, that may give us ideas in the future about how to modify maybe even the syntax of the main language to do some things better. Okay, before we continue, someone is saying, after watching some of that, I'd beg that you made some of those user-facing types more approachable when it comes to metaprogramming. Some of those types you needed to cast from were getting intense. Okay, I need more information. What did you think was intense, right? If you're saying that those types had a lot of stuff, like if you mean this kind of thing, you need a lot of stuff because you need to know everything about the program, right? So if you're saying I should have less information in these types, then that's not how it's going to be. But I'm not sure that that's your objection. So what is your objection? Nobody's answering my question. I'm asking OFX 360 for more details about what he's saying. Well, we're not getting an answer to that in a timely fashion. Maybe he's on break as well. So, in which case he didn't hear me ask that question and won't answer it when he gets back. So I think we just have to go on. Someone's saying, so is the default args info not simply available to the meta at this point? Right, we're not passing that information out of the compiler. I could do that, but I'm not sure that that would be the right way to implement this anyway, because the thing is that the expression inside the default argument could be arbitrarily complex, and it could use names that are not being exported to the place where this generated compile time procedure is going to live. Maybe in the future we'll have the ability to poke generated code into specific namespaces. In fact, we will probably need that at some point. Or this kind of exercise is showing that probably we want that. But absent that, I don't think we should try to duplicate. We shouldn't try to call the procedure duplicating its arguments. We should instead call it with the number of arguments that we were called with, which means we'll do some ugly if statements, but it's fine. It's totally fine. Yeah, you can't get away from having all this information because this is the information you need in order to do stuff. Like types in programming languages are just not simple one or two field things. They tend to have a lot going on. Now that said, this may not be the most user-friendly way to present what is here, and I'm totally for hearing suggestions on how to take the amount of information is here and organize it in a way for people to deal with better. But like, this actual information needs to be present in whatever the solution is, or it's not a solution, right? You gotta let people do what they need to do. He is asking, when calling def a of z, comma b, comma c equals 1, d equals 2, can you call A of 2 comma D equals 1? I don't understand. You gave me a 4 argument thing and then a 2 argument thing. I don't understand the question exactly. Because you're skipping B, which had no default value. If you didn't mean to skip B and that's a typo, then yes, you can do that. There's an entire, you can use named arguments to skip other optional arguments. There's a whole demo of that on YouTube. Yeah. Yes, you can do that, yes. Okay, I'm going to plow ahead with the dumb solution that I'm thinking of. That's going to generate a code that's a little bit uglier, and then we will see if there's a better way to do it. So people can feel free to criticize what I'm about to do. Let me put it that way. So we're going to do 2 loops. We're going to declare the variables, and we're going to assign values to the variables. In the declare the variables part, we're going to declare up to the maximum number of variables we will need, right? So we're going to look at the argtype. We're going to make a line just like we did. Since we're going to check the type here, we don't need to check and give an error message down here in this bottom loop, which simplifies that, which is nice. Up here, we're going to say just the type, int, right? We're not totally handling we're going to do something else ugly down here. So I just realized we're saying this is an int, but we're calling procedures that may have integers that are smaller or whatever, and we could check for overflow in a more advanced version of the compiler, but for now we're going to just jam autocasts in everywhere. Anyway, all we're trying to do right now is declare the guys, because we may not have values for everybody. And in fact, let's declare them as uninitialized. And like I said, we're going to need to jam these in with an autocast. I just realized. So we're going to put double X's there, and we're going to say robustness. In this initial version, we XX all the arguments so that we can pass an int to a U8. We just did this so we can be lazy about the type declarations above. I am a bad person. In a future version of this code, we can cleanly detect overflow, etc. 30 January 2017. Okay, let's see what that does. Okay, so we've got our XXs, we've got our declarations, but now we're redundantly declaring them. So we want to change these to just equals. And here's how we're going to do that. We're going to say if arguments.count is greater than whatever, and we'll put it in braces just to be super clean. If arguments.count is greater than whatever, and if we, after adding more types, we get chafed by this redundancy, we can factor that out. That's fine. So we're only going to initialize the things that we got, and the other ones will remain uninitialized variables. Am I forgetting something? I don't think so. So now we've got that, right? Oh, whoa, dear, what? I need another I. Okay, so we declare the maximum number of variables we will ever need. Okay, and this is a little bit dumb, this arguments.count is greater than whatever, because we could not emit, you know what? Okay, let's factor that out. Because we're going to want to factor it out later. It's fine. So we're going to say line equals sprint this stuff, right? And new line, I, and inner, we're going to have something called inner that we set here, right? And inner is going to be something simpler that just says, you know, arguments of whatever, or this is going to be easier to understand. Get integer of arguments of whatever, right? Okay. Why so? Oh, we don't need all the spaces either. Great. Okay, cool. Wait, what? Did we not? I didn't say Emacs didn't. What? Okay. There we go. So this is good. Now we only need this if we're greater than okay. Line is a string. If I is greater than info.min args, right? I think that's right. We'll check it. Else, we just need this part. There we go. Whoa. That's not right. Okay, so in this case with add, where we know that we have to pass 2 arguments, then we're always assigning this, right? In the case of ls, where we don't know, oh, ls isn't right. So I guess it's if I is greater than or equal to min r, right, because there's an off by 1. Right. Okay, so ls checks I0 is uninitialized if we have no arguments, or we assign it to argument 0 if we have 1 argument, right? Now, and add, on the other hand, always just assigns, it doesn't do an if. Now the last sauce is we have to call this with the correct number of arguments. So here's what we're going to do. This is a little bit saucy, but here's how we're going to do it. We're going to factor this into get proc call string for some number of args, right? And we're going to do all this stuff, but we're just going to go to args, and this returns a string, and we're going to say get proc call string info.max args. So this should just do exactly what we already did. If not all control paths return a value because return arg string. And attempt to use a variable from an outer stack frame args. Okay, this should not do anything new. We just refactored, and indeed it doesn't. So now what we're going to do is we're going to say, in order to keep things clean, we're going to say if info.min_args is equal to info.max_args, we're just going to do the same thing, simple case, else we're going to say for I in info.min_args to info.max_args -1. That doesn't feel right. Min_args. No, we don't put the -1 because -1s always still confuse me, and I've been programming forever. So in the case where, in this case where we have ls, we have 0 args or 1 args, right? So we want to say arg string is get proc call string of I. So we're generating a whole new call string every time, and we're going to say line is sprint 1, 2, 3, 4 if arguments.count is equal to whatever, do whatever. Decal.name arg string and I. This is ugly and stupid, but it'll work. Okay, so here there's nothing different, right? Here there's nothing different. That's good. Here, oops, I didn't actually add the line. Array add lines line. Okay, nothing different, nothing different. On ls, where's ls? Okay, well I forgot a brace. But you see, if arguments is 0, we call with 0 arguments. If it's 1, we call with 1 argument, right? Okay, let's put the closing brace, because I'm a dummy. And you know what? We may be done. So it looks to me like this code that we are generating will now swap in for the other stuff. Someone's asking, will I be adding closures eventually? Probably, yeah. I think closures are cool to have. It's just, they're not as important as functional language people think they are. So they're relatively low down on my list of things to add. But as I finish other things and add other functionality, they creep closer and closer to the top of the list. Up a page or so, my sprints have too many arguments called I. I really should have argument checking for this. Let me see. 1, 2, 3. Oh, geez. Right, because I broke these up. Yeah, I need, like one of my first demos was checking arguments for printf, and then I've just never reinstated that since then. Thank you for catching that. Okay, so this is good. So let's take out the comments. Here's what we're just going to go for. Well, srn commit. We're going to go for it now. We are going to, I've probably overlooked something, but we're going to comment out all this stuff, and we're going to uncomment this metaprogram that we are generating. Where's the close comment? There it is. Well, yeah, let's keep that. All right. Oh, forgot my @leak. Yeah, that's true. All right, guys, what's going to happen? Who wants to take bets on what happens? Here's what's going to happen. This isn't the kind of language that's going to have yield. Sorry. I'm not so worried about the at leaks, because really what happens is if there's any leaks in some code, what that means is that's a signal for me to audit the whole procedure. It's not like I'm only going to pay attention to the, yeah, it's fine. Oh, it's not, no get integer? Oh, that must be at file scope. Okay, let's fix that. I really am going to want a way to go into a specific scope. And issued error is also not file scope. And, oh geez, all the command, okay, basically, we're just not going to do scope file here, is basically what is happening. Because until we can insert stuff into a file scope, is not good. Okay. Now, who wants to take bets on what's going to happen now? Let's look at that. It compiled, so that's pretty awesome. And look, we've generated all our fronts. So for people who tuned in lately, the capsule summary of what we just did was we allowed a programmer who wants to add commands to a game to just write the commands straight up, taking arguments of various types, although we only handle int and string yet. We'll handle others soon. I'll do float next, maybe. We allow people to just write these and tag them as register command, and when you do that, the compile time metaprogram will dig them out of your program. It'll automatically generate these procedures that register your command with the console and do type checking on the arguments and pass the proper number of arguments. So I am praying now that this will work. And dude, this hardly took very much code. Like our number of lines of code was like 36 something high, and now it's 37. Even though you might look at this metaprogram stuff and go, oh, that sure is a fair chunk of code, it's like, well, let's see how many lines it is. So line 253 to 415, you know, it's 150 lines, 160. That is pretty short. Like the system to do all this stuff in the witness is larger by a factor of 5 or 10. Because C++ don't help you with this stuff. All right, let's run it. ls. Oh, we called ls with an argument. Oh, but 2 arguments. Oh, it's at most 1 argument. Oh, add 1, 2. Quit, blah, blah. Oh, you got to have 0 arguments. Okay. Are there any questions about that? Because that is great. It's, you know, it's been a long stream, but, well, probably not longer than average, but we did a really cool thing. Like, all I have to do is add one of these. What if I add a command called hello, right? And I print, or no, we'll command output hello sailor. Let's not put the new line. And it'll have a default argument of do leaves, or number of leaves is an int, and it's optional. And if leaves is greater than 0, we're gonna say s is sprint, there are % leaves in the pile with leaves. If leaves is greater than 1, no, if leaves is greater than 0, s is a string. If leaves is equal to 1, else there is 1 leaf in the pile s equals that, or else equals that, command output s, put that in here. So if we get no leaves, actually, let's just do that. right? And at register command. So all I have to do is register this as a command, and I get all that machinery that we just wrote, right? I don't have to think about the fact that it hooks into the console. I don't have to check the argument types. Oh, we should try, okay, we may not be done. Let's try my command first. Hello. It says hello, sailor. Hello, 1, 2, 3. Up at most one argument. Hello, 0. We'll just say hello, sailor. Let's get some extra console. Hello, 10. There are 10 leaves in the pile. Hello, 69105. There are 69105 leaves in the pile. Look how easy that was. Okay, that didn't work. Oh, because we don't, okay. When we get a type error, we're not reporting an error to the console. We're just aborting the command. So you see it didn't run the command. So let's actually report an error if we like can't parse a string or something. I thought get integer. Okay, we got to do this. We should tell people which argument it is. So our get integer is going to take an index. Someone is asking, would it be possible to create new commands through the command line? Well, you would have to like hook the compiler as a library. Eventually that'll be possible. Am I going to put those primitive type parsing functions in the standard library? Probably. Will console support scripting like if then loops expression? Probably not, because that's not the kind of console that I'm making right now. We're not going to try and implement a whole other programming language. If you got to the point where you wanted a programming language, you would do something else than what I'm doing. This is just for quickie, like I want to call functions. Hello has a default arg, yes, but I changed it to 0. You might have missed that part. So hello's default argument is 0, which means don't print a number of leaves in the pile, right? It was 69105, but I changed it. I left bool on command add. That is a good point. Thank you. That is not necessary. Do I find myself that the features I implement in the language are pretty much, blah, this would be a good time to use blah, or do you find it more, now I have to restructure, change, fight with the code to use blah? Well, it's mostly the first one, because most of the features that I've put in are things that I've found myself wanting over and over from programming previous games. So it's very rare that I'm adding something that I don't already know how to use. But sometimes, you know, and that's what I'm doing here, is I'm learning how to use what's here and, you know, deciding if it needs to change or whatnot. Okay, here I need to say issued error, and I'll say error sprint error argument whatever is not an integer, comma, index +1, defer free error, and command output error. So now we will actually say something, but we need to pass these to get integer now. So in our metaprogram, when we call get integer, we need to pass I. So now if I say hello, so 33, that works. There are 33 leaves in the pile. If I say hello and something else, argument 1 is not an integer. Hey, isn't that cool? We got all that for free. We just had to type our hello. Isn't that great? That's so cool. Which video on YouTube would be good to see how you achieve such fast compile times for the game? Well, you know, we never really went through and showed me optimizing things on stream. I did a demo of how fast things are, and Well, we did during that demo dive into a profile. I forget what that one is called. Let me see. YouTube demo backend speed up, I think. Yeah, so in this demo, I'm probably talking over it. So I demo things going fast, and then I show the x64 backend, and then I think this is the one where we go into telemetry. Yeah, so we start diving into what's taking how much time. So that'll, I think, yeah, see, we sort of dive into the profile and, you know, sort of inspect what is taking how much time and stuff. So if you want to know what is happening, then there you go. That was done in December, I believe. And command hello, I didn't free S. Well, command hello isn't going to live very long, but yeah. Technic Beam says this is really cool. Thank you. I think it's cool too. One of the high-level design goals for this programming language is to make it easy for your program to communicate with itself and for external systems, right? So this is an example of your program communicating with itself, right? Like it can look at this and can expose this stuff in a type-safe way, right, with the runtime. And that's what's great, is like, you know, it's not like we're JavaScript where you type a, you know, if this were JavaScript and you like said hello, blah, 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 it would just think that's an integer or something, right? Or actually it would think it's a double because everything in JavaScript is a frickin' double. Well, no, it has integer types now, I guess. Whatever. ECMAScript. Have I used swig? I don't remember what swig is. Okay, let's add floats. Let's add floats. Let's make hello be, take a float, and that's it. We'll leave it exactly the same, it just takes a float. We never tested that error message, so now we have registered a command that takes a float, so our compile time should get angry at us when we try to compile and say, bad. Let's see what happens. Yeah. Argument 0 at line 136. We said error twice, but line 136, argument 0 is of a type that is not handled yet by command registration. So let's go do that. By command. Let's take this out because we used to just print that, but compiler report error says error colon. All right. So let's say else. So a lot of what we did was just foundations. So if we want to handle new types, it's actually not particularly hard. So we put that, and now we just need to make a get float by copying our get integer, right? So if we compile now, it'll complain there's no get float. Wait, what? Wait, what? Number mismatch. Oh, did I not save in time? Emacs sometimes I hit save and switch windows. I copied the wrong. Wait, what? Oh, that's what I did. Okay. So now it's complaining we haven't defined get float. Oh yes, Technic Beam caught it. Thank you. Someone is calling me from San Francisco. I don't want to answer the phone. Thank you. Okay, so now we're just going to go here, and we have a get integer, and we get a float. And I'm just going to copy all this stuff, and I'm going to say, if it's 0 to 9, else if c is equal to character dot, we are good, else we issue an error, argument whatever is not a float. And we return A to F. And we return, this is called get float. And we say float. A to F gives us a double precision. All right. So that wasn't very hard. We added float, and it was harder than it should have been because of my dumbness. So let's see. Hello. Hello 3. See, we didn't have to put the decimal point. We just got 3.0. Hello 42.6. 42.599998. Hello. Do-do-do-do-do-do. We're out of precision because we're single precision floats. Hello. Let's. Well, what more is there to say? Oh, get float doesn't handle negatives and accepts 1.2.3. Okay, if you're going to get picky, if you're going to get, I was all happy. Let's handle negatives. If I is not equal to 0, I should make a convenience function that does all this stuff, like I said, but that's going to happen later, so we're just going to paste it. Error stray minus in argument whatever. And that's not I, it's it. And if it's a dot, we can only have one. So num dots is 0, or found decimal is false. If we hit this, found decimal is true. But if we already found decimal, we do all this stuff, which we will simplify later. Error extra decimal in argument whatever. Used here but shadowed later in the same block because I did the yeah. All right. Hello 1.2. Hello minus 69105. Oh, that didn't work. Why not? And we didn't even get an error. That's weird. Okay, that worked. I mean, you could also like stop parsing there and break that into a new argument, but that's not how our parser works yet. Hello 69.105. Hello 6.9.105. Extra decimal. So, we have this problem though. We're not parsing minus anything. Why not? What the hell? What the hell? Sorry. Calling A to F minus 1. Dude, A to F, how does that not work on negative numbers? Wait, it must work. No, hold on. We must have set issued error. Wait, what? Wait. No, it is getting run. It's just, we're getting 0 back for some reason. That's bad mojo. What? Wait, does my hello sailor... I bet this is an x64 backend. Oh, we just checked greater than 0. Thank you. Someone said that in chat like 10 minutes ago. 2 people said it and I wasn't watching. I thought it was a serious bug and it was just me being dumb, which is always what it is. There we go. Okay, so now we have relatively even more robust float support. Cool. Let's get rid of these prints. Great. So now we support float and int and string. And that feels like enough for now because it's been enough streaming today, don't you think? I feel like that's a good end to today's programming. That feels good because when I started this stream, I wasn't sure how we were going to do the metaprogramming, and I wasn't sure if I was going to hit some wall where I couldn't quite do everything I wanted to. But we totally did. Like this thing that we ended up with, let's even delete this stuff. So the thing that we ended up with is so clean. Let me just put these at the bottom, like commands go here. Like that's all you have to do to make a new command, and it's just hooked into the game, and it's type checked, and it's great, man. Oh, that's perfect, basically. I can't imagine doing better. Well, I probably could, but well, one thing we can do better is check for overflow if we pass for like small int types and stuff here. Which, did I write that down? Command dispatch checks int overflow. That'll be fancy because we don't even do that in the witness. Although in the witness you're not allowed to have like an unsigned 8-bit argument. You just, you know. Oh. You know what? That'll be fun because I could write something like check overflow going from T to R, right? And I could do it really funny, like I could say actually you want it to be a type. Wait, how would this work? Because it has to be dynamic. Has to be dynamic. Okay, you couldn't do it this way because you only have the necessary data at runtime, but at least I don't think you do it that way. Anyway, I had fun today. This was good. This was a good day's work. This is going to be posted on YouTube if you missed any of it. And I'll probably do a gaming stream in a while. I need a rest, but I'm going to rest and then do a gaming stream because there's a game I want to try. instead of register command tag, you could make a tagged block or section where everything inside is implicitly tagged. Yeah, you could. Except the one idiosyncrasy of the way things work right now is that these notes only go on declarations. So like if you made a block, you couldn't put that on there because it's not a declaration. But that'll probably get fixed in the future. We're working these things out. Negative integers. Oh God, I wanted to go and somebody brought up the point that I didn't do negative integers. Oh, you people just ruin my day all the time. All the time. Okay. And who took an integer like that integer? Wait, I can't even tell now. Command add takes an integer. Add 3 to minus 3, 0. 3 to minus. Oh, I say that for everyone. Let's not spam people. Break. Oh, yeah. Return 0. Return 0. Return 0. Okay. Add 3 to minus 99999. Ah ha ha. Negative integers. Someone is saying, no, look at my comment, but I don't see his comment because it's way up. It's way up. Oh, check out the code. That's off topic, man. I'm too tired for off topic. Check out the code keyboard. Fine, I'll check it out. Assuming structured notes in the future, will you still have support for string notes some other way? It would probably just be a struct with a string in it, right? For this, we actually would rather have structured notes. Not because we want to pass arguments or anything, but because we want to not misspell this accidentally. And who knows, in a large enough program, there could be somebody else looking for notes called register command that means something different. So if it's a structure that you're looking for, you can make sure it's in the right namespace and thereby know you're running the right command. So, you know, really in the long term, this should be structured, which doesn't even mean, like, it might look exactly the same. It might just be that this doesn't end up as a string. Like if there's no arguments, you probably don't even have to do that, right? It's probably just that. And this will map to a struct in a namespace that these have access to. Completion ain't happening today. Sorry. Later. Have I looked into the Magic 468? No, everybody's so excited about keyboards. I just did something way cooler than keyboards, man. This is, not to belittle keyboards, because a lot of great engineering goes into modern keyboards. But yeah, I don't know. I output strings for generated code. Could the language output it more directly? Almost. So the way it works right now is you can take a procedure and read its syntax tree and modify the syntax tree and hand it back and say, recompile this. The thing is, there's no facility for adding a new procedure with an arbitrary syntax tree. That's well within the capabilities of the compiler. I just literally have not done it. And I also haven't made this facility for specifying what scope new things you add go into, which is why we had to make all this stuff global here, because everything by default goes into global scope. But once I figure out how to express that in the nicest way, then we'll probably build that. Yeah. All right. Goodbye, everybody. I'll be back for a gaming stream in a while. I don't know why I'm streaming so much lately. It's just what mood I'm in. And later I'll be in a different mood. So even though I'm doing more stream hours per day than anyone can reasonably watch right now, it's fun. So see you guys later. See you guys later. Thanks for the positive comments. I like it.